Okay, I'd like to know if I'm in the field of view here. There you go. All right, very good. Okay, so welcome everyone to the August meeting of the Stockton Astronomical Society. We're trying something new tonight. It's all due to COVID, of course. We're trying to set up a system here at Oak Grove Regional Park so that we can actually have meetings here and also have it at home for those that don't wish to drive this far or can't make it for whatever reason. So I'd like to welcome all of you. And this evening we have a really neat speaker, and I don't know you personally, Mel, but everything I've heard from Jeff is that you are a world-class ATMer that everybody considers a guru, and I think he's right. But prior to that, before we start, we've lost a really special member and friend to our club, and I would like Tim to say sort of, I think he has something worthwhile saying, and he was really a special man. That was Don Mackelsley, the astronomer, comet hunter extraordinaire, and I don't think there'll ever be anyone quite like him.
Okay, thanks, Mike. Eric, will you put the slide up, please?
Let me share here.
We'll congratulate you at the end of the meeting, Eric, if everything's successful. So far, you're doing great. We'll come back to the announcements next. If you go to the next slide, please.
Did everybody see the In Memory of Don Mackells?
Yeah.
The photographs covered up here. Okay, so Don was a special member and guest visitor, presenter to Stockton Astronomical Society for many years. I never met him in person. I think a few of you have, but he was on our meetings when we started meeting on Zoom quite often. I spoke with him over the phone a couple of times, and then I listened to his broadcast on his podcast weekly for over a year. So I really felt like I got to know him. So when I heard earlier this week that he had passed away, it was a really, really sad news. So I grabbed this photograph and this article from the Earth Sky magazine and website. They published it. So if you don't mind, I'll just read this to you because I think it summarizes in Don's life really well. It says, we are heartbroken to announce the passing of Don Mackells on August 9th this year at his home, Stargazer Ranch in Arizona, under one of the darkest skies in North America. Don was a friend and a colleague at Earth Sky. Indeed, he had a great love of the night sky and shared his boundless knowledge with our readers using his characteristic wit. We send our condolences to his wife, Michelle, and his two sons. Don, the comet hunter. Don became interested in astronomy at age 8. And with this in mind, he received his first telescope on October 7th, 1965. That's how long he had been observing. He started out with this 2-inch refractor. Later, he received a 6-inch dynoscope and found all the Messier objects in 1 year. Consequently, he decided to attempt a comet hunting program, which he began on January 1st, 1975. So he must have thought that Messier had really done something by trying to find comets and then creating that list. So I assume that's where he got the idea. He found his first comet on September 17th, 1978, after 1,700 hours of searching. Subsequently, his second find took an additional 1,742 hours. Eventually, he spent 8,900 hours comet hunting, during which he discovered a total of 12 comets, which bear his name. He was, in fact, the #1 living visual comet discoverer. Nobody else has 12 comets with their name on them. He pioneered the Messier Marathon. In 1978, Don was one of the independent inventors of the Messier Marathon, an attempt to find and view all 110 galaxies, clusters, and nebulae in one night. And in the last 40 years, he completed over 50 Messier marathons and wrote 2 books on the subject. From 1978 through 2000, Don wrote a monthly column called Comet Comments for Astronomy Club newsletter and interested individuals worldwide. Between 1988 and 2000, Don was the comet record for the Association of Lunar and Planetary Observers, and Don continued his visual comet hunting and Messier marathons from Arizona, where he lived with his wife, Michelle. And then this article doesn't mention, I had mentioned earlier, he published the Looking Up with Don podcast for, I think, over 2 years, weekly updates, what to see in the night sky, and really, really informative. Just the basics of what you're going to see in the night sky. Don was great at describing and pointing you to them. So with sad heart, we bid you clear skies, Don, and we really enjoyed having you as a member of our club. And then, Eric, if you go back to the announcement slide, we'll just run through these announcements real quick. These are the upcoming events in August and September. Doug has a special outreach program this Saturday night here at Oak Grove with the Girl Scout troop. Doug, you have your volunteers lined up for that?
Yeah, Tina and Bill will be out there with me. If somebody else wants to join us, that would be great. Actually, not a lot of room. There's only about 30 Girl Scouts. Once again, seeing another scope out there, another person. We'll be meeting out, not where we normally set up, but over on the east side of the park, where the Girl Scouts will be camped for the night. The moon doesn't come up till about 9:30, but Saturn will be up a little before then. And then until then, I don't know much what we see how dark it gets, but yeah, so just come out and join us.
Very good. And then we have our August 20th and 27th star parties. And then coming up in September, another astronomy in the park on September 3rd, our general meeting on the 8th, Highway 4 on the 17th. And then put this on your calendars, everybody. Try to make the September 24th high altitude star party and potluck. All looking forward to getting together up there into some good dark skies. So, Mike, I'll hand it back to you or to Jeff to introduce our speaker.
All right, hi guys. It's glad that we've kind of got our game back on. Mel, this is kind of a different thing for us. We've been Zooming only for a couple of years now, and so finally here we are at a meeting with a place. We haven't done this in a long time. We don't have a whole lot of people here. We still have a lot on Zoom, but it's a start and it'll build up. So we're a little bit dry running tonight. Tonight we have Mel Bartels and his presentation called Faster and Fainter, Drawings with a 30-inch f2.7. And I really wanted to hear this talk because I've seen his drawings and I can't believe he can see the things he can see and draw them so well. It's just a whole different level of astronomy for me. A little bit of background on Mel. I've known of Mel for a couple decades because he's the world's ATM corner guy. Everything that's ATM, Mel's got the answer for it. He's written the algorithms and code for a lot of the Dobsonian tracking software that we use. He's also a musician. I think you're a trumpet player, if I remember, and a pilot. His deep sky drawings with large aperture, fast focal ratio, rich field optics gives him a huge field of view and very deep into the sky to see incredibly faint and detailed stuff. As far as ATM goes, he's, like I said, the go-to guy, and he's got a couple things that I find interesting. Most of us start out making a mirror with the same size pitch lap as the mirror. And then later on, when we make larger, faster mirrors, we usually have a smaller pitch lap than the mirror. Mel has larger pitch laps and mirrors on lots of his projects, and I honestly have no clue how you do that, Mel. I've tried not to get into that, and I might someday, I don't know. And he also tests pretty much exclusively by creating a Ronchi pattern and then Ronchi gramming the telescope and then comparing the two and working the telescope mirror until the patterns match, which I have also not done. And I find that would be difficult. At the same time, I don't know, I haven't tried it, but his mirrors turn out to be, optically perfect. There's no such thing as perfect, but Mel's as close as it gets. Another thing he has done is written a lot of articles for Sky and Telescope, one of which was a double altitude bearing Dobsonian telescope, which is genius because if you're familiar with a Dobsonian, when you get up to Dobson's hole, the zenith, it goes up and down, then you try to go the other way and you got to torque that scope around. Well, it has a second altitude bearing, it just moves it around. It's just easy as pie. It was genius to come up with that. And I've always thought that was a really cool invention. He's been in Sky and Telescope as a contributor many times. I see him on a daily basis on Oregon Scope Works. It's a forum of telescope makers and mirror makers. And I get a whole lot of information out of there. And he puts on a program every summer, the Alt-Az Initiative, which is where people get together and collaborate on up-to-date new technologies for building large aperture, fast focal ratio, alt-azimuth telescopes. So for every bullet I just listed, he's got about 1 million more. So Mel, I'm so glad that you're with us tonight. Thank you for presenting to us. I'm going to hand it off to you now.
All right, well, thanks for the introduction, Jeff. So I presume you can hear me. So let me go through the process of sharing my PowerPoint. And by the way, I'll talk a little bit about the telescope. It's behind me. But more about that in a moment. All right, so let's see what we can do here. Oh, can you enable screen sharing for me? I'm not a host.
Right now? Looks good now.
Okay, so it looks like you can see my screen okay then.
Just FYI, we see your screen with the slides on the left.
Yes. Let me try going full screen here. And that.
If you do start the presentation, you might have to reshare another screen if you have more than one screen.
Okay. So how are we doing now? Can you see my screen share full screen?
That's great.
Okay, great. So thanks again, Jeff, for the introduction. I understand we're in a hybrid situation, so if you have comments or questions, let's see if we can't become a little more conversational at the end of the meeting. So faster and fainter drawings with a 30-inch and a few thoughts about designing telescopes. So I think about John Mackles is that he didn't let the advent of the automated survey slow him down. And, sometimes I feel as a visual observer, I'm among the last living dinosaurs as technologies encroach and light pollution occurs. So I always just admired his courage for continuing on despite the competition from the digital electronic side of things. So remembering those who've gone before us, besides Don, we also lost Steve Swayze a few months ago. Steve happened to go to my high school. He was about 4 years younger than me, but I did not know he was interested in astronomy until a few years later when I had my 24-inch at a star party outside of Portland. And you know how it is in the dark, you recognize people by their voices. And I hear this voice behind me going, Mel Bartels. And I turn around, and of course you can't see. So I go, and who is this? And he goes, Steve Swayze. So I knew Steve a little bit from his older brother, Bruce, who was in the band with me. And it turned out that Steve and Bruce had gone to the Bay Area and learned telescope making and mirror grinding from John Dobson and Earl Watts and that group of people, and returned to Portland. Steve had an 18-inch at the time. And so he sauntered up the ladder to my 24 and took a look and came back down and said, well, I got to have a 24. And so next year he did have a 24. But the thing is, he didn't stop there. In short order, he had a 30, and then he had this 40-inch. And I didn't think the 40-inch would work. I thought the stars would be blobby, you might resolve the Airy disk. And I thought the 24 I had was really the ultimate aperture. But Steve proved me wrong. And you know, it's a strange thing. Of course, the ladder is almost as impressive as the scope. And I helped him a little bit carry the mirror around. And it would take 3 of us to carry the mirror, and we would go to his brother Bruce's office after hours and take the mirror and roll it down the hallway so that we could have this nice testing. But here are experienced observers whom I respect and admire, coming down the ladder saying, you can't believe it, it's just incredible. Well, I don't know, until I could see for myself, I guess it's just this bias of seeing is believing. If you don't see it, you sometimes find it impossible to believe. So I go up the ladder and I take a look, and I think they were on NGC 7331 at 750 power. And my gosh, it looked like Andromeda in my 24. And I too came down the ladder going, you won't believe it. It's pinpoint stars. And so I completely revised my thinking on super large telescopes. Steve and I conspired for a while afterwards to see if we could build a couple of 50 inchers, but we could never come across the glass blanks that were affordable for us. So sadly, we lost Steve. I thought he was so bold and creative and doing what he did. And then there may be others that you know of. They don't have to be well known. They could just simply be people who enjoyed a connection to the sky. Speaking of people who passed on, just before Ed Hubble died, he wrote, but with increasing distance, our knowledge fades and fades rapidly until at the last dim horizon, we search among ghostly errors, observations for landmarks that are scarcely more substantial. The search will continue. The urge is older than history. It will not be satisfied and it will not be suppressed. So when I move out of my telescope making mode and into observer mode, I let the telescope guide me to what it can show me in the sky. I really did not anticipate I would be returning to galaxies. I figured my 30-inch has a degree field of view. I'd be looking at wide angle impressive objects and not get sidetracked in the galaxies, but I quickly got sidetracked into galaxies. A 30-inch is a galaxy munching machine. But there's something new about a 30-inch with a degree field of view. Not only can you see the antenna galaxies with the tidal streams, but also just at the edge of the field of view is another galaxy that looks like half of the antenna, and together they comprise this wonderful view. So I began this slide into looking at tidal streams. That's the faint pulling apart and stretching and destruction of galaxies that are being gobbled up by the larger galaxy. Here's one of my favorites, NGC 4013. And it has this beautiful arc of tidal galaxies curled around. And I just thought this was so wonderful. So I looked for some more. And this is 4651, and has a little bit of tidal streams, and then a little bit clump of material actually on both sides there. But also you can see on the far left is a little bit of IFN, or integrated flux nebula, or galactic cirrus. That's gas and dust that have been blown by supernovae far above and below the galactic plane. And although there's a blue component to them, it's mainly dimly glowing in the red and the brown. And I see this galactic cirrus, or IFN, on, if I go back and look at my drawings, about 2/3 of all the drawings I make have it. So because of the wide field of the 30-inch, I get this perspective then. So here is quite the controversy, 5907. So I didn't realize it when I observed it, but I was very pleased to see, and I'm going to move my mouse, and hopefully you can see a little palm, but although the galaxy is immense, it goes from edge to edge in the field. There's a little bit of brightening here that I saw, and a little bit of a curved arc right here that I saw. And so that's part of the tidal streams to this galaxy in Draco, but I also saw some integrated flux nebula with a little bit that approaches the galaxy here. So I got later to see if anyone had imaged these tidal streams. And sure enough, here are two photos on the right-hand side. They're scaled, oriented, and matched. And they're supposedly a 5907, but they look quite different. So there's quite a controversy apparently about this galaxy. And perhaps if you have some aperture and dark skies, you can go out and see what the deal is for yourself. These two are just not reconcilable as far as I could see, but my gosh. And by the way, these are exposures in luminance of dozens of hours. And so it's astonishing to think that just by looking through the eyepiece and giving yourself 20 minutes to an hour, that you can see these structures yourself. So that's quite interesting. Here's ARC 102, again with some IFN. There's a band that goes right through ARC 102, and then here's another streak of a nebulosity or galactic cirrus over here. And this is probably more mundane. After I drew it and sharing it with others, I was told that this part right here is quite unusual to see. So if you go looking for this one, go check that out. Here's 3310 plus the shield. It's actually showing a little faint on my screen. And in 96, terribly bright galaxy, but the 30-inch has enough aperture and resolution to show this knot over here in the spiral arm. And this is an embedded galaxy that just happens by coincidence to shine through the arm there. So with the wide field, I look for combinations of objects. This is the Owl Nebula, along with Hickson 50, a little group of 5 or 6 galaxies down there to the far left. And I can just barely get it into the same field of view, which I find to be just a wonderful presentation in the eyepiece. And if you look across the bottom of the field of view, some more galactic cirrus shows up there too. 4565, no galactic cirrus here, but it is astonishingly bright and huge galaxy in the big scope. And here's William Herschel's, among his favorite galaxies. He called this the double galaxy. And there's galactic cirrus going right through the field of view, right here. So the two up here, and then the two down here. I think sometimes it's also called the hockey stick and the whale, but that is very pretty too. All right, so enough of galaxies. Well, maybe not quite done with galaxies. So this is the ring, and this galaxy up here, which is what, IC 1297 or something, I find this to be really difficult to see. I mean, I hardly ever see it. But on this night of wonderful transparency, you know how you set your eye up with averted vision, and then you lock everything in place, and then for a few seconds you get this view before transparency seen, and then the jitters of your eye, you lose it and you have to reset again. So every once in a while, this galaxy here, which is normally impossible for me, or is maybe just the tiniest of fuzz, would come in with this huge size to it. And it was so fleeting. But also this outer ring and the glows and streaks up to it. I'd never really seen that before. On the right-hand side is my drawing through the 25-inch. And I just think that the view through the 30 is far better than the view through the 25, more than the 30 to 25 ratio that you might expect. So that to me is a bit of a wonderment. And sometimes it feels like as you go up in aperture on these objects, you cross a certain threshold where you break through and you begin to see stuff. In the 25, there are hints of the outer boundary, but in the 30, you can see this outer ring part glowing. It's just the most amazing sight. And then the Pelican, this is a multi-field sketch. And the 30-inch with the degree field of view, you can wander around quite a bit and trace out this wonderful object here. You know, there was a time when I couldn't see the North American at all, and then I learned to see the Gulf of Mexico, and then after a while, you could kind of tell that the Pelican was there, and then you got used to seeing it. And now it's just this wonderful object with these dark extensions in through here that goes on for field after field. Just incredible. So Messier 5, I was looking at that on my way to Palomar 5, and there's an IFN right next to it that I've never seen anyone image or draw, but it's pretty obvious. And then when you do get to Palomar 5, which is a surprisingly difficult globular, in the 30-inch, you see a sprinkling of faint stars and a fuzz behind that. There are some brighter stars that cross it. I don't know if they belong to the cluster or they're just foreground. But it's kind of thrilling to see these really difficult objects resolved. And then among the first drawings I made of the 30-inch was the California. And I was so surprised that, first of all, you can even see the California in a 30-inch. Normally that would be overkill. But the California into 30 breaks apart into this banding structure that is just really pretty. All right, then. So how did I get into the 30-inch? Well, I started with this little 6-inch, and you can see me holding it there. It's actually attached to the 30 now. And the first night, I took the 6-inch out to see if it was going to do anything. I thought, okay, well, the Pleiades are up there. Let's just aim at that. And so I aimed at the Pleiades, and it was really beautiful. And I noticed this stain, and I just thought, oh no, what has gone wrong with the telescope? I mean, there's this, like, the eyepiece is ruined, or somehow the telescope is no good. And then, of course, the object gradually moves, and so I recenter it, and I go, wait a minute, that's part of the Pleiades. What is going on here? So it turns out the Pleiades has this bubble, which I rediscovered. And Walter Scott Houston, somewhere in the 30s and 40s, had pointed it out once. And then in the late 1800s, it had been observed. But apparently, every 30, 40, 50 years, it gets seen and then forgotten. Well, now, because of the internet and so forth, other people have gone out and seen this, and it's a subject of images and sketches and so forth. But wow, you know, what a first light object to see, and to go from thinking that somehow you just spent all this time on a disaster of a telescope to seeing something really new and unusual. So then I began to get adventuresome, and I thought, well, and so I'm just scanning around the sky, and I see that there's this ring of darkness around Betelgeuse. And I go and look, and I think it's actually called Pickett's ring now. Someone found this imaging, but you can see this quasi, it's a series of dark nebulae connected together, if you will. a ring around it. It's just a startling structure. And then on the right is one of my favorite drawings I made of the Cone Nebula with the 13-inch. It's just amazing with the wide field what you can see. Okay, so then after a few years of that, one night I thought I would try observing IFN. Steve Mandrell with the Impossible Nebula Project, I think he called it, had imaged these, and I was aware of his paper, but these are impossibly faint objects. I mean, they're around 25, 26 magnitude per square arc second at brightest. But I thought, well, what the heck, you know, you won't see if you don't look. So I pointed my 10-inch up there, M8182, and to my utter surprise, the field was filled with this nebulosity, and it wasn't particularly faint either. I mean, that was doubly astonishing. So you can imagine the thrill. You're in the darkness, it's quiet, and you see something that you don't think is visually possible, and you just wonder, you know, who else has bothered looking for this? And it was just an incredible experience. So I thought, well, in for a penny, in for a pound, faster and fainter I go and go. Well, it turns out that a few others in history have seen IFN. But before we get to that, I'll show you some of my drawings. So this is with a 10-inch on the left, and this is the first IFN that I saw. And you can actually see that there's some shape and structure to it. Steve nicknamed this the volcano. Here we can see it's kind of puffing out some smoke there down to the lower right, and M8182. And yeah, it's just incredible. On the right is the Co-Cam IFN. This is coming off the Angel IFN. And I think it's one of the most beautiful structures in the sky. You can see the faint circles, which are the 2.5-degree field of view of the 10-inch. And it's a double arch, but the upper arch is actually doubled itself again. And it is just beautiful. And you could just follow these and stretch it around and stretch it around. I eventually succeeded in seeing this with binoculars. And then this year, I was finally able to see it with the unaided eye. However, I'm convinced I am not the first to see this with the unaided eye, because going back years at the Oregon Star Party, people would say, hey, can you see the Milky Way going to Polaris? And yeah, I could see the streak there. And they go, did you know it goes past Polaris? And I would like, okay, well, this is the nebula that streaks past Polaris. So I think people have been seeing this and not understanding, thinking it was part of the Milky Way, but it's actually IFN. Anyhow, these structures go on for large stretches across the sky. So the Andromeda. So this is a sketch of the 30-inch. But the second object with the 6-inch, after I observed the Pleiades bubble, I thought, well, just for fun, to relax, I'm just going to look at Andromeda. And as soon as I got Andromeda, I could see two things I'd never seen before. First is a twist. And then secondly, I could see that this debate as to whether the galaxy is 2.5, 3 degrees or 5 degrees in size, both are true statements. If you take the spiral part of the galaxy itself, that's about 2.5 degrees. But if you take these extensions that come off of here, which were brazenly bright in the 6-inch, that's 5 degrees across. And as you begin to look, you can see that it's filled with this bright galactic cirrus through here. One experienced observer who has one of the largest telescopes in the world looked through my 25 at this, and I'll always remember him staggering backwards going, whoa, not only can he see it, but it is bright. You don't even need to use averted vision. And all these years and decades and hundreds of times I looked at Andromeda and I hadn't seen this context around it. So in the 30-inch, what surprised me and knocked my observing eyes off their socks, if you will, is that I can see these parts through here broken up into smudges. And I found this deep exposure over here, and sure enough, you can see these puffs here through here, a little bit over here too, and then this arch down here. And if you look at this, it's hard to go, so this is centered on the Andromeda coincidence? Are we sure it's part of the Milky Way? I even heard one professional astronomer opine that maybe this is forward scattering or something. So if you put your finger over the M31 galaxy itself, it doesn't look quite so coincidental. It just looks like a big puff of galactic cirrus, but is an amazing view through a wide field scope of any size in dark skies. Okay, so let's talk about the first person that we know to see galactic cirrus in IFN. And it turns out it's William and Carolyn Herschel. So here we have a picture, a portrait done later of William Herschel the night he discovered Uranus. Now there's some problems with this picture, and I invite you to take a moment and see if you can see what they are. I wish people would be a little bit more accurate when they recreate famous moments in history. The first is that this implies an equatorial mount. See a little wheel down here? They did not have equatorial mounts back in the day. Also, the tube is round. That's not how scopes were made back then. They were planked. But the biggest problem with this is actually what he didn't see. So as he would often say when asked, oh, you know, you're just a lucky devil, you know, you found Uranus. And he's like, no, I was destined to find it. If not that night, another night, I was doing my sweeps systematically, covering the sky. I would have come across it. And he's exactly right. But the question is, then why in the heck didn't he find Neptune? It was well within range, well within his sweeps, and somehow he didn't find it. That's the real question, mystery and history of William and Carolyn, probably the greatest observing team of all time. Why didn't he find Neptune? Well, shortly before he died, he made the comment that he had concluded that the sky floor, or the background, he called it the sky floor, varied everywhere he looked. And he cataloged 52 nebulous regions. Some of these nebulous regions have since turned out to be the Horsehead, and so on and so forth. I was just reading a paper again the other day saying that, well, you know, most of these are probably illusionary. But I have matched up some of his nebulous regions with some of the 120 plus IFN that I have drawn. And I'm pretty convinced that his other nebulous regions will prove to be galactic cirrus too. And I also have come to the conclusion that when you pay attention to the context of the fields of view in dark transparent skies, the background in most of the fields vary. You can see variations. And once you become sensitized to that, you cannot ignore it. So I do walk over to people's scopes and I'll go, oh, there's an IFN in there, and I'll describe it to them. And they'll like, wow, there is. I have no idea. So for example, let me just jump up here real quick. And we'll go to right here. Did you see the glow in the lower right of the Ring Nebula? How many times have we looked at the ring and not seen that there's a galactic cirrus there, a brightening in the field? So Herschel was the first to see these. All right, so Andrew Common, invention of the telescope is the most beautiful ever made. Familiarity increased my admiration. As you probably recall, he was a self-made man and got into astronomy, and he set about to make a 60-inch. The first one he made produced elliptical stars. We know that's stigmatism, but that didn't stop him. He went about producing a 60-inch again, the second one. That one he was successful and made round star images, but he had a near fatal fall, almost died from falling off the ladder. And so he changed the configuration from Newtonian to something else. And that mirror lived on as a Harvard 60-inch and went off to, what, South America or something. So anyhow, I always admired him that he would just go and make a 60-inch. All right, so there's my 30-inch. And you can see it's on the floor observing and the silvered mirror. And oh yeah, so the 16-inch. So I know you're watching my presentation. I don't know if you still have the speaker view over there, but if you do, I have the 16-inch right here. And it's just 3/8 of an inch thick. It's meniscus, it's f2.9, it weighs 7.5 pounds. And this is now a finished mirror. And yes, I do use my matching Rocky. I use the star test to do the final figuring. And so there we are. So this is my next project. Okay, so now also, if you can switch to the speaker view and make that a little larger, I was going to show the 30-inch just a little bit. And you know what, maybe I'll just stop sharing so I can see what's going on here. And I'll switch to a speaker view, and all I get are you people there in the auditorium. So we'll go back to here. Okay. So what I wanted to do, first of all, you can see the silver mirror there. What I wanted to do was show the 3-axis motions of the scope, because I think this is actually one of the coolest features. So all right, so nothing surprising. The scope moves in altitude and azimuth just like we expect it to. Okay, so now I'm going to point the scope upward, and you can see that it naturally transitions to an altitude motion. Okay. So there we are in altitude, just like you would expect.
Oh, boy.
There we are in the other altitude. Now, the beauty of that is that I don't have to grab the upper end and force the scope around in azimuth and rotate the view and cause all sorts of trouble. It just naturally transitions from Alt-Az to Alt-Alt. And then somewhere in the middle, around 75 degrees, it's doing a little bit of both motions. So I find that pretty useful. And again, no ladder on the scope. Okay, so let me go back and see if I can share the presentation. Okay, so are you back with me? And we're on M16?
Yes, we are, Mel.
Great. So I do not own an NV device, but Ed Allen, who built Elvira, does. And you may know that when I made this 30-inch mirror, it's 5/8 of an inch thick, f2.7, weighs 38 pounds, which is just wonderful in all of the, but I made 2 mirrors at once. My hypothesis was that I could do that most of the time when we make a mirror, we're actually learning how to make that particular mirror. And indeed, that turned out to be the case. Whatever I did to one mirror, I did it to the other mirror, for better or worse. And let me tell you, that was hard. My hands were shaking. I had to like almost slap them. If I did something bad to the first mirror, I had to go do something bad to the second mirror too. That was not easy to do. But I did prove that the parabolizing actions are amazingly consistent. Whatever happened to one, it really happened to the other one exactly. And really the problem is me. I need to not do bad parabolizing actions from time to time, you know? So the second mirror then ended up with Howard Banich. He used it to replace his Steve Kennedy 28-inch mirror, and had a chance to use it with Ed Allen's NV device. And as you can see here, Ed goes on to say that at GSSP, it offered the best NV image he ever witnessed, including much larger scopes, because I think at the silvered coating, the best way I can describe the NV image is crisp, sharp, contrasty, clean, and quiet. And so he says, after we played around with some stuff, that the image on the left was, without exaggeration, what they were seeing through the NV device. And so I thought, okay, so silver 30-inch or silver mirror with NV device has some possibilities. So apparently they, and sadly I was not there, so I did not get to see that. Okay, so what's the explanation then? Well, I think the simplest way to look at all this is this concept of étendue, or light throughput. And there's really just two parts to it. One is aperture, one is field, and that's light throughput, or étendue. So on the top, we have the CoCam IFN with the 10-inch on the right, and on the left, I manipulated it to show what it looks like when I stop the 10-inch down to 8 inches. You can see it, but it's fainter, and that's pretty realistic. So aperture makes a difference, makes the objects brighter. And we are talking diffuse nebula here. So the second aspect of étendue is field. So on the bottom, whirlpool, exactly the same scope, same magnification, except that on the left is an 80-degree eyepiece, on the right is a 100-degree eyepiece. Same brightness, the IFN looks the same, but to my eye, the view on the right is easier to see because there's more context, more framing, if you will, of the IFN. So étendue as aperture and field is you simply just multiply the area times the field. And so you get this number in square centimeters, square degrees. And when you use a 100-degree eyepiece with maximum aperture, you get an étendue number of about 2,500. So we'll keep that in mind. And that's it. You know, it's just aperture and field. Okay, so let's take a minute and talk about how a telescope works, which I think is a marvelous thing, and it's not easy or intuitive to understand at all. And, you know, Galileo famously conspired to keep a telescope out of Kepler's hands because he was so afraid that Kepler would figure it out, because Galileo had tried to figure it out, but he couldn't. Well, Kepler went ahead and figured it out anyhow and wrote his theory of optics without a telescope. But you can see that we have an entrance pupil on the left. That's just the size of the mirror of the lens. It produces a image here at the field stop, the size of which is dependent on only one factor, its focal length. That's it. And then we have this eye lens here that re-images this real image into this area called the exit pupil, which is not an image, and into your eye. Now, not to confuse things too much, but this exit pupil right here, where the light all congregates and goes through, is an image of the aperture, and that's important. Okay, so let's talk about this in real life. Here's my 13-inch f3. Primary mirror, 13.2 inches. The entrance pupil, therefore, is 13.2 inches. Here I put in a 17 ethos with a coma corrector, 1.15x magnification factor, 100-degree apparent field of view. And so the exit pupil comes out to be 4.8 millimeters. In fact, it's so tiny here that I magnified it so you can see this here. So we have this tiny, tiny exit pupil where your eye goes, and this big entrance pupil down here. The magnification up here in the upper left is simply the ratio, 70 power. The real field then is 100 degrees divided by 70 is about 1.4 degrees. And oh, space penetrating power, where does that come from? Well, this is how William and Carolyn Herschel rated their telescopes. They took their apertures and compared them to the 5mm exit pupil, which he felt was a good standard low power pupil to use. And so when you do that ratio, it's 67 for a 13-inch scope. And then resolution is about 3.5 arc seconds at this power. If I want more resolution, I have to go to higher power. Okay, so here's my low power observing scheme. And you know how you have high power eyepieces, you have one eyepiece give you 200, another one 250, another one 300, another one 500, and you kind of slide back and forth based on scene and the object. You know, Saturn, for instance, can take, on a night of good scene, can take a surprising amount of magnification. Well, it turns out that there's a lot of benefit to doing the same on the low power side. If you can get several low power views in there, there's really nice contrast and perspective to be gained. So I know that there's a fair amount of money invested in that. Obviously, I didn't buy them all at once, but if that's more than your budget, there are 80 to 90 degree eyepieces that are far less expensive that will nearly as well fit the job. But let's take this first one. So in the 30-inch, the Explorer Scientific with Beta coma corrector, which is what's in the scope right now, actually gives me a 1.14 degree field of view. And the Entendu is limited to 2700 by my pupil. So don't pay attention to the man behind the door. Don't look at the 9.2 exit pupil. Yes, I am throwing away light. I'm probably the equivalent of 24 inches of aperture, but what really counts is for this field of view, I have maximum Entendu, and that's really what I'm interested in. If I take the ES25 and put the TeleVue P2 coma corrector in there, now I'm at a degree field, exit pupil is 8. I'm still at maximum Entendu, and you might think, 1.1 to 1 degree, you know, but when you go back and forth between these two, it really makes a difference. You do see more detail at the 1 degree field, but you are throwing away some interesting stuff that you can't see all at once. So following the same thinking, you jump up to the 21, and now you're at 0.9 degree, and now it does fit your eye. And the Entendu is, again, pretty close, or is at the maximum you could do. And then finally, my last low power eyepiece is an Icon 17. It's 3/4 of a degree field of view, 5.5, 5.4 to be exact, millimeter pupil. And now the Entendu really drops off. And when I look through the scope and I look for these faint parts, whether it's parts of the Pelican or integrated flux nebula, they are starting to dim, but I do get more detail and delineation that I can't get at the lower power. But any more power than this, and it's like falling off a cliff, it just disappears. So really low, faint stuff just is no longer there. So those are my 4 low power range sequences I do, just like you might do at high power. Now, remember when I said that Entendu was aperture times field? Well, it turns out that Entendu is also your pupil and the apparent field of the eyepiece. So if you take your pupil, 7 millimeter, we'll just say, and we apply 100 degree apparent field of view eyepiece and calculate it out, you get the same number, 2500, 2800. And so we can see then that the entrance pupil and the exit pupil are connected together through this concept of Entendu. And in fact, there is a conservation of Entendu law that says you can never increase light once you get into the system. And this is why those attempts that people have made occasionally to do a multi-mirror amateur scope, you know, let's get 4 scopes together and put all the light together. Even if you could combine it coherently, which we have yet to do, but even if you could do that, it does not result in a 7 millimeter exit pupil. The law of Entendu says that you will end up with a 10 millimeter exit pupil or whatever it calculates it out to be. And so nature conspires then to limit us to this. And that's the best we can do at low power. And that's my explanation for why these are visible. Of course, the apparent size has to be big enough that you can notice them. So then, if that's the case, what can we do to increase that sensitivity? Well, if you're into the wide field observing, you'll go get a wide field eyepiece. But what can you do on the aperture side? Well, if we start with f10, how about if we go to f8? Or, well, let's get a bigger mirror, f6, f5, 4.5, f4, no, stop, f3.5, f3, f2. So you can keep going and going and going and trying to squeeze more mirror into this focal length, because we know that focal length and your eyepiece and solely those two determine the true field. So the only variable left then is to try to squeeze in more and more aperture, get more mirror curve in there. And, on these thin meniscus mirrors, everyone talks about the thinness of the glass, but if you ever make one, you'll quickly discover that the thinness is not the problem. It's the overwhelming parabolization, the deviation of the paraboloid from the spheroid that is your challenge to face. And so at some point, then you say that's as much aperture that you can squeeze into, and that's your entity limit. So then, if that's the case, then we should design telescopes based on our true field. So on the left is a drawing of the Tulip Nebula with my 6-inch. And the tulip part is just this little part right here, but you can see this fantastic nebulosity all around it. Everyone zooms in on this part, but there's this wonderful field of view to be had. That's great for the 6-inch, but when you get to the 25-inch and the tulip fills up half the field of view, yes, you can see the shock wave to EGNIS 6.1, and that's really special. And you see some of these nebulous streaks and so forth, but you surely do not see that broad context in the 6-inch anymore. But you do see something different. They're just two different views of the same object. So what we really need to do then is consider having more than one telescope. So after I finish the 16-inch, I'll have the 6-inch, the 10-inch, the 16-inch, and the 30-inch. And they all fall on a line, and they all allow me then, if you look at the graph over here, to alter my field, to go from 5 degrees to 3 degrees to 2 degrees to a degree by varying the size of the scope and using that then. So what do you do then if you want even more power than this, if you will? Well, go build a 40-inch or a 60-inch or an 80-inch. Now, in reality, we can't do that. So, when I get to my largest aperture, the 30-inch, then I am forced to go into what I call eyepiece mode, to go higher and higher in magnification. But, once I drop off and into do, those really faint structures disappear from the field of view, which is fine if I'm looking at a planetary or a globular cluster or something like that. So, oh, well, how about, I wonder what William and Carolyn Herschel thought about all of this way back in time. Well, he too, turns out, had a range of telescopes that largely fit within a line. And his 7-footer, 10-footer, 20, and 40-footer with matching apertures. And he too kind of standardized, I believe, a 5-millimeter pupil is what his eyepieces were set up for as he went back and forth to look at scopes. So that all being said, I still love an 8-inch f7 or a 10-inch f5 or 12-inch f4. And yes, if I get carried away, I'm going to end up with my 16-inch f3. But the point is, if you have one scope, it's so much more powerful than the eye. You can't go wrong with one of these scopes. But I do feel like a dinosaur, and or maybe I'm in the wrong age, or somehow I've gone to sleep overnight and woken up in some type of parallel universe, because there's new observing experiences now out there that don't use eyepieces in the way we think we do. They are popular at star parties. They're I guess you could say they're not marketed to people like me, but surely they are going to have a large say in what the future of amateur astronomy is. And so I'm just wondering what faster and fainter we'll have to do in this world, but that's what I'm doing now. So that's my presentation, and I sure appreciate your attention, and I'll stop sharing here, and maybe you can offer your comments or questions.
Anyone's question? Mike has to over there.
That was awesome, Mel. When you were talking about the 30-inch over the 25 seemingly having more light grasp than what you would have thought, is it because the 30 is silvered and the 25 is aluminized?
Maybe, our silvered mirrors are turning out typically to be 98, 99% reflective. A little less so in the blue. Now my 25 had the top end ion, bombarded, assisted, enhanced aluminum coating. But that's not the only object that I've seen the 30 outdo the 25 on. And if I think of it in terms of the 30-inch has an 80-inch focal length, 80-inch focal length. The 25 was only a 60-inch focal length. So maybe that's the difference between 80 and 60 inches focal length. And it's not really the 30 to 25 aperture change, but yeah, it's a significant difference between those two scopes.
Also on the IFNs, just to clear things up for me and everybody else, they are material that are intergalactic, not stuff that's in our galaxy.
Our galaxy.
Oh, they are in our galaxy.
Yeah, sorry if I misled you. So we have the galactic plane, and when supernova go off, it throws material hundreds to thousands of light years up and down below. And that stuff then glows in reflected light and reflected heat from the summation of all the stars and energy sources in the galaxy. And it glows in the red, infrared, this kind of brown, dark red color. And so we call it the integrated flux of the entire galaxy being reflected and glowing from this IFN. I think the professional astronomers refer that we use galactic cirrus as a term, but no, it's in our galaxy.
Oh, thank you, because I noticed that you were showing that you had galaxies with IFNs, and so I thought, okay, so they're related to the galaxy targets, but they literally are just random chance.
Yes, and the reason they're associated with galaxies is because we're looking away from the Milky Way, and on very dark transparent nights with wide field scopes, with observers who are paying attention to the wide field, you can see these galactic cirrus or IFN glows away from the Milky Way, and they're literally almost everywhere you look.
Thank you.
Okay, Mel, I'm looking at your drawings. I've never tried one before, and I can't even draw a circle, so I think I'd be in big trouble. But I noticed that when you draw nebulosity, everything, the amount of subtle detail, what are you using, charcoal or pencil? How do you get these subtle details without smudging?
Charcoal and pencil on white paper. I do a final or presentation drawing that night or the next morning from all my ink scratches on paper and so forth. Usually I can't figure out did I do 2 scratches or 3. So invariably I have to go back and answer questions on the second night that my first attempt at drawing poses to me. So almost all those observations you saw are 2-night observations where I spend at least 1 hour, if not 2 hours, on the object. And I know it sounds intimidating, but years ago in pre-COVID times, I gave a talk to the Eugene Club, and there are, I don't know, 40, 50, 60 people there. And we had conspired to buy everyone drawing equipment. And it was only like $3 a person, because you only need a stub, an eraser, a clipboard, a piece of paper, and a charcoal pen. And so on the planetarium screen, I projected a planet, a nebula, and something else. And I just said, all you people are artists now, so let's draw those. And the amazing thing is that everyone produced useful drawings, but what people zeroed in on was different. Some people might zero in on the rings of Saturn, and other people really concentrated on the belt or something. It's just the variation of what you paid attention to, what you saw, and therefore what you drew was interesting. But the point is that even without any practice or any technique at all, people produced stuff that was useful. And I have to say, my skill is not that good. If you look at a Howard Bandage or someone else, I mean, those people are artists and people who can draw, trying to faithfully show what you see through the eyepiece. So yeah, you just get in there and yeah, you know, get a good sized waste basket and lots of printer paper and you know, wrinkle it up and throw it away and do it over and over and over again. And gradually you'll produce something that isn't so terribly embarrassing. And you go, hey, that's a drawing, you know, and off you go.
Is it helpful to beforehand get a photograph and put the dots where the stars are and then take those dots and fill in between them with your details? Or is that not something you do?
You can do that. I don't think there's any rules and it's not anything illegal that you can do. There's nothing wrong, for instance, if you're concentrating on the nebulosity, for you to take a piece of paper and print out, have on your printer, just print out from Sky Safari, 8 or 10 bright stars. It helps you triangulate and figure out, okay, is this nebulosity a third of the way over or 3/8 of the way over? It's okay to do that and just, you know, mark it in. You can do the final drawing at the eyepiece, or like I do with ink scratches, you know, you just say that, and I'll just write 3/8 with an arrow showing 3/8 of the way over. And then on your final drawing, it's okay to take that, trace over those stars and fill in the nebulosity where you saw it. It's quite legit to do that. If you're looking for a globular cluster, of course, you're not going to just trace stars. You're going to, you know, look and fill in patterns of the stars that you see. And globulars at first are really intimidating, but they are not actually impossible to draw at all.
I have one more question for you, if you don't mind, Mel. Your big, beautiful telescope behind you there with the dual altitude axes on that. I'm assuming that a sidereal tech drive system would not work on that, or would it?
Well, a 2-axis drive system, if you lock one of the axes, it will work. But the pure solution would be to go ahead and make a 3-axis system.
So Mel, just to let you know, Mike here that's sitting next to me that just asked that, he's the guy that's got the 32-inch f2.84 down here that we put together a few years ago.
Right. Well, you know, I built a 3-axis drive system. But Dan Gray to go 3 axes. Just lock one of the axes and drive the other 2. There's ways around it. The beautiful thing is that if you do go with 3 axes, you solve your field rotation. You don't need a field rotator if you do that.
Ooh, that's really tempting. I really don't want to tear it all apart and start over, but when I look at that scope, I'm thinking, boy, am I in the dark ages? So
yeah, people don't understand to get a successful drive system, how many hours it takes to tune them and get them set up. And my gosh, you know, you don't want to tear it apart. Yeah.
I figure at my age, by the time I figure it out, I won't want to use it anymore. So that's another real serious issue.
Well, you know, when I do my drawings, I actually move the scope around quite a bit because I don't limit myself just to the field of view, but I'm always scanning around. So, so for me, I really would like a 3-axis drive system, but it's okay that I don't because I'm just constantly moving the scope anyhow. So a tracking isn't that good for me, but yeah.
I think the difference in deep sky observing is interesting. You're working at or near Ridgefield. I look at my deep sky with an 8mm ethos. I like whacking the power up and spreading the thing out. And it's interesting that both worlds are very useful.
Well, I can do that too. If you have a slower scope than mine, mine's 2.7. If you're at f4 or something, you're naturally going to get higher magnifications easier than me. But I can put an 8 ethos in or 6 delos or whatever until I run out of power. But the way I look at it, and the way I would encourage you to brainstorm it, is that you have that, let's say we have that 8 ethos in there. And that's what magnification would you be at? 400 power or something?
Right about there, yeah.
Yeah, okay, 400 power. Okay, so why wouldn't you go and put a 60 or 70 inch mirror behind that then and go back to a 20 millimeter eyepiece? Same field, but you've just pumped in all this light. I mean, wouldn't that even be better?
No, don't tempt him.
So anyhow, that's my thing, is that so we got to figure out how to make these mirrors lighter and easier. And if the focal length is kind of the real thing, this is just an 80-inch focal length. I mean, a 10-inch f8, right? That's pumped up with 30 inches of aperture. So that's kind of my new perspective I've gradually come to.
So like on your globular clusters and your ring nebula, I have the feeling that you were at a much higher power when you drew those.
Maybe 300 power, whatever scene would allow, sure.
Yeah, okay.
But I'm not going to stop looking at them because I don't have a 16-inch scope, so I can't look at M13 at high power. No, that isn't how it works. I'm going to look at M13 at high power and go, oh my God, and all this kind of stuff. And then go, this is impossible to draw. It's way too many stars. And you go, oh my gosh, 6207 now starts to show structure, but I'm also in the back of my mind going to think, well, maybe someone like a Jeff Baldwin could build a 70-inch f3. I'll go down and look at M13 with that.
Well, when you said you don't have a 60-inch scope, you forgot the word yet.
Well, so in case you don't know, I've been working my way up from 13 inches of aperture, trying to figure out how to make these ultra thin mirrors work. And the 25 and 30, if you look at the background, they're on the grinding machine. You can see a couple of 42s. So we'll see. But, I can only do what I can do. And each mirror is a major challenge in several different ways. But once we figure it out, then maybe it won't be so much of a challenge.
Well, I've got my 40-inch, 3/4-inch glass cut out, and I'm waiting for you to get through with yours so you can tell me how to do mine.
Well, you first.
We'll see. It'll be a while. I cut a hole in the center of my 40 with the idea that I would be doing my transverse support with a shaft in the middle. So we'll see if that works out or not.
Right. Lateral support on these mirrors becomes a major, but there's no law in physics that says it's not doable. And if you calculate out, even on the back of a piece of paper, simple engineering formula, you go, oh my gosh, the 8-meter Gemini mirrors are impossible. You can't do them. But the pros are doing them. They're supporting them. Maybe a little more sophisticated than what we could do, but surely we can come close. So that's what we need to figure out, though.
Are you doing your own silvering of your mirrors?
Yes, I am. I follow the recipe that the Oregon Scope Works group has pioneered. So there's several things to say about the silver mirrors. They aren't for everyone. They don't last forever. This one here is about 8 months old, and I figure I'll get about 1.5 years out of it. But the beauty is that the night I silvered it in the afternoon. That night I was observing. And I just thought, wow, for $2,400, I could have shipped this out and a couple, 3 months later gotten it back. And then I would have been forever scared to ever clean the mirror or do anything to it. Yes, so I do them all myself. It isn't just the money saving, it's some of these other advantages to doing it. But the reflectivity and how they look, it's a different look than aluminum. I've bumped it several times with my hand now, not realizing that the glass was so close to me, because there's just no surface to the silver. Like an aluminized mirror, you can usually tell where the glass surface is. But on the silvered ones, on the good silvered ones, it's just like looking through something, and you don't even hardly see the glasses there. And the star colors and the contrast is just jet black right up to the, the edge of the star. I think it's subjectively a different view through the eyepiece with the silvered mirror.
And you're saying that the lifespan on that silver surface is how long? Of a year and a half, you say?
I hope I get a year and a half out of it.
And the price difference is?
So I spent $400 to get set up with all the chemicals and everything. And then that will last me for several silverings. And the last someone told me a couple months ago, 30-inch enhanced coatings were going for over 2,000, 2,400. So.
Thank you.
I just want to make a comment or a question for you here. On that beautiful scope behind you, did you just by coincidence put that eyepiece at your eye level, or was that planned from day one? I think I know the answer.
You mean like when it's up at zenith?
Your eyeball is right on the eyepiece. I love it.
Well, so I'm not actually quite sure what you're asking here. So.
Oh, okay, let me restate that. When you have your telescope set up and you put your eye on there and you're looking at the zenith, your eyepiece are pretty much online. I was hoping I could do that with my scope, but the aperture is a little too big for the F number. Did you design the whole thing so your F number would work out so that your eye level and the eyepiece would be the same? Does that make sense?
Yes, right. So kind of. So here's the deal. When Jerry Oltian, who lives in Eugene, came over to do the Sky and Tail article on my 25, and he took a flash picture of me looking through the 25 with the 25 aimed up at zenith, right? And he goes, Mel, you're bending over to look through a 25 at zenith. You're not even standing up straight. I don't know that we can use this photo in the article because you look bent over. And so I thought, aha, maybe I could squeeze a ladder-free scope up to 30 inches. So that's what I tried to do. And I spent a lot of time with CAD trying to get the bottom of the rocker, to scrape just above the ground so the scope would be as low as possible. But I didn't point it out earlier, but I'm going to try and do it now. I'm going to move the scope up to vertical, and then or near vertical, and then you'll see that what that third axis does is it allows me to position the eyepiece angle. So when you're near zenith, you can actually reposition the scope so the eyepiece points downward by a few inches, and then you don't need that little step stool.
If it's not proprietary information, could you show us a little bit more how that out mode works?
Yeah. So what you have are what I call a double flex rocker on a flex ring base. All it is two thin flex rockers at 90 degrees. And the top one looks just like the traditional Dom, as we know. Now the bottom one works the same way. The question is, of course, is that you'll turn it into some kind of weird ball scope or something if you don't limit the motions. I limit it to 15 degrees. But smaller scopes, you can do more. So that's basically it. And you just put the two at 90 degrees and draw it out. And it'll be self-obvious when you do this.
Wow, thank you.
Mel, are you using a coma corrector?
Yes. So the P2 coma corrector normally, but the beta coma corrector in the 25 millimeter to give me that 8 or 9 degree pupil, the star images are surprisingly good. You know, it's low power. I wouldn't necessarily use it at medium or high power. Definitely by the time you get to the 8 ethos, you want to have the best coma corrector you can at f2.7. But the beta coma corrector, because it does not add magnification, it helps me with the widest field, and it's a reasonable coma corrector, surprisingly so.
Okay, anybody else have any questions? Mel, this has been really awesome. I'm so glad that you're able to join us tonight and not only talk about the IFNs, but your ATMing and designing and everything. It's just been great. Thank you very much.
Well, you're welcome. Thanks for your attention. And Jeff, I look forward to that 40-inch and then that 60-inch sooner than later.
Well, I don't know about a 60, but the 40's coming. Right after you get your 42s done and can tell me all the engineering problems you run into.
Yeah.
I haven't asked you yet. I was going to email you this, but I'm coming up to Washington in within a month, and I was hoping I could stop by your place on the way up and on the way down and check out some of your stuff.
Sure.
Yeah, like
I'm
I just
actually in.
invited myself publicly there.
Yeah.
I'm in Central Oregon on the east side of the mountains. So yeah.
Oh, here we go.
I had to ask you just a little quick question. I noticed that you're working on Sisters. I've been there a number of times for fun. Where do you find a dark sky out there? Because the town itself is pretty bright.
Yeah, the town lights. I don't know what to say, you know. There's so many amateurs here, and you know, our neighborhood where I live, we're about 5 miles northeast of Sisters. We're in a neighborhood of a couple hundred homes, all on 5-10 acres, and no one has their lights on at night. Doesn't matter if you look through your scope or have one. People just enjoy the darkness, and so I don't know what's wrong with the town itself, but the people who living right next to it are not so thrilled anymore because it's been growing like crazy, and the lights just foreshadow this growth. But a couple 3 miles away, it's really dark. And the way it works for me is that when the air is really clear, there's nothing that reflect lights back. And actually, although I'm 120 miles from Portland, the light pollution of Portland is actually the worst pollution I face here. Not Sisters at 4 or 5 miles away, not Bend at 20 miles or Redmond at 20 or Madras at 20. It's Portland and Salem over the mountains. I can just see that glow.
You observe from your backyard, or you find some sort of an area that's more protective from light pollution?
Just my driveway. I just wheel the scope out and observe. So it makes
I'm
it super
jealous.
convenient.
Now, that's not fair.
Well, I'm retired, so this is what we did. So.
Oh boy, puts a whole new meaning to moving. Okay, any other questions?
Yeah,
I have a question. I wasn't familiar with the term ND device. Can you explain what it's about?
I'm sorry, you broke up there. What word?
The NV device. Can you explain? I wasn't
Oh
familiar.
yeah, the night vision device. So what are they running now? Like $3,000 or more? So it's the electronic intensification based on electron cascading amplification inside the sensor. It came out of the military for their night vision. And so it's been adapted for astronomy uses now. And it's not anything like apparently the ones from a few years ago. The new ones are white and they're like super resolved and they do not scintillate or anything. And I do not have one. It's really pricey, but more and more amateurs are getting them. And so, yeah, I have to tell you one story. So a few years ago to OSP, someone brought one along, and And they all wanted to see what people were doing in their tents. And so I was like the only one saying, let's just put it on a telescope. Can we just put it on a telescope? I think we know what they're doing in tents. So finally I got someone to put it on the scope, and it was really spectacular. It's not the be all and ends all. It's nebulosities. It is really something. Stars a little bit too. Galaxies, no. But anyhow, I'm talking to the guy, and he goes, yeah, I went to a David Douglas High School. And I went, oh, I went there. And he goes, and he started talking about this girl. And I go, oh, well, I knew her. In fact, she was, well, and he goes, yeah, she's my wife now. And it's like, okay, stop talking. We're not going to say anything that she hasn't told him. So anyhow, it's a funny story of who you run into in the dark years and years later. You know?
Anybody else have any questions? Well, Mel, thank you very much. We're probably going to move on to a business session part of the meeting here, and you're welcome to stick around if you like. This has been really entertaining. Thank you very much.
Okay, thanks, everyone.
Thank you. Thank you very much.
All right. Okay, folks. So that was fun. I could talk to you all night about telescopes. Mel, boy, do I have a lot to learn. Anyway, let's continue on, folks. I think probably, Jeff, you should make a little speech about the equipment manager and what's involved.
Yeah, I'm really, I know I retired, but I'm really, really busy. I've got business things happening that I'm buried. And so I've already said that I'm not going to run for an office next term, but I'm also ready to hand over the equipment chairman to whomever would like to take that on. It's not a big job at all, and it's all, it's on a PDF right now, so that I was talking to Eric, it's easy to transfer over and stuff, but I am looking for somebody else to take that task away from me. So that was my announcement.
Okay. So this won't be immediately, but as the year goes by, the sooner we can get started on that, the better it would be. Yeah, okay. That's according to Jeff. Okay, very good.
Thank you.
All right. Do we have anybody with any announcements or questions or anything on agenda that we haven't covered?
Just real quick, while everybody is still on the Zoom meeting here, since this was the first time that we have done this sort of hybrid in-person and virtual meeting, overall, how does everybody think it went, especially those that are remote, not here at the Nature Center? Did everybody hear us okay? Was the video okay? Any choppiness or bad audio on your end? Does anybody have any comments that they'd like to make?
This is all good from here.
Worked well.
Yeah.
Perfect. Great.
So I have a question. Would any of you be interested in joining us at the Nature Center? I know it's easier from your home, but it's a lot of fun to get together and talk and chew the fat and compare things. And we would like to have you here if possible. What do you think, guys and folks? No comment. Okay.
I'd like to go to the Nature Center.
Just think of the good old days when we got together at UOP, and it was totally different when we're with each other than when we're looking at each other on the screen. Plus, we have cookies here.
We may limit the door prize to those who attend rather than those that watch us.
You
There you
sold,
go.
sold me on that one. I would like to attend. Unfortunately, I travel on business. I'm on business travel right now, but the video, the Zoom meeting worked well, except when Mel did his resharing, it never came back up on my screen. So I had to listen through his calculations, which was fine.
Did that happen for anybody else? Did you guys lose his sharing?
No, I didn't.
Okay.
Seemed to work okay.
But it's really good to have it, because that means I can attend more meetings even when I'm traveling.
Yeah, I think this is still a good idea, and we would actually have more participation.
Yeah. So kind of on that note, I wanted to extend our appreciation and recognition first to Doug Christensen for securing the Nature Center. He's worked for years to foster this relationship with San Joaquin County. And it's just working out great. We've got this meeting spot now. And so Doug, thank you very much. Don't be modest.
I would like to interject with that because it's not Doug that set this up. This is Sandy Adams with the San Joaquin County Parks. And the reason we're able to use this is because people like Bill, Eric, Paul, and Tim, and the rest of you guys come out and do astronomy in the park. Because we're out here with telescopes in the park, these are the people that make the room possible, okay? So it's not Douglas, it's the volunteers that come out, like Dennis and me and so forth, all right? So these guys, the people that volunteer actually.
Yes. You're the last one leaving tonight and closing the gate, so
Yeah.
thank you for that, yeah.
So the rest of it is Eric.
Yeah, that's the other recognition I wanted to make, and appreciation, Eric. If you guys could see the cables and stuff strewn about this room, all this electronics here, Eric has worked hours on getting this to run, so.
Thank you.
And not only that, Eric's probably spent over $1,000 of his own money on all of this stuff. Ouch.
Not that much, not that much.
So what I would like to bring up is in order for this to happen, we're gonna see if we can get San Joaquin County to do some of this stuff for us, okay? They are willing to make this room a little more usable. So some of this stuff, San Joaquin County will pick up, but Eric still needs to do the technical work on this stuff, okay? And that's, yeah, it's a lot of work for him, all right? The other thing I wanted to bring up is because I guess our bylaws say that the club, that the executive council cannot spend money on anything other than what's in the budget. We put this thing together and it had to come out of our pockets, okay? So I think we will be coming to the group with some ideas on how to change the bylaws, okay? So that the executive committee in these emergencies can do what's needed and spend the money that's needed to keep this thing possible. All right, so that's got to hit to the newsletter first and so forth, but I think that process is going to start. All right, yeah. So I just figured I'd just bring that up now because like I said, it was relative here and now that we couldn't do this if it wasn't for people pulling money out of their own pocket and making it possible. All right, I'm done. Michael.
Yeah, okay, since Jeffy's mental computer was not able to come up with a winner tonight, simply because we had such an outstanding guest taxing our my limited brain, let's put it that way. We're going to postpone it till next month, and then we'll have a winner for the drawing on that. Sorry, guys, but anyway, you'll survive. Okay, any other things to talk about, folks? I really enjoyed myself tonight. This was a great talk, especially if you're an amateur telescope maker. Boy, talk about a wealth of information coming through there. And really, I don't like him anymore because he's way light years than anything I've ever done. Yeah, he makes it look easy. Okay.
Yeah, folks, I got a couple of comments. First of all, Mel was terrific, incredible. And the other thing I'd like to say is just some words about Don Mackles, because I didn't know Don very well, but I actually really re-met him through the SAS meeting earlier this year. I actually first corresponded with him way back in 1974 when he sent me his observations of his telescopic meteors. And then I met him for the first time in about 1985 when he came to our astronomy club in Southern California as a speaker. And I heard about him in the news, you know, and all that, but I never really communicated with him. I knew he was up in Forest Hill for quite a number of years. And so it was really a delight back, I think it was in February and then a couple other meetings when he joined in. And I was actually able to say, hi, Don, nice to see you again after all those years. I don't know if he really remembered me, but that was a real special gift. I'm really sad to see him pass. The second thing is that just to let you know, our member Dominic Nuccio is hosting a star party tomorrow night up at his place in McKellamey Hill. I believe that's pretty close to the Perseid meteor shower, of course, a full moon. So it's for club members. I don't see it. I don't think he's advertised it in our newsletter, though I think he was going to. So anybody wants to come up or their guest to his house there in McKellamey Hill, if you're interested, you can give me a telephone call or Dom, and we can give you any directions on that. I know it's full moon, so there's no dark sky anywhere, but you're all certainly welcome.
Any other announcements, comments, or anything? Otherwise, I will close the meeting.
And we'll eat cookies.
That's what you're missing by not cooking. Cookies, that's really important.
I'll be right there.
About an hour away or so.
Thank you all. Good evening, and thank you for your attendance. And we'll look forward to seeing you guys again next month. Okay.
Yeah, folks. Good night.
Good night all. Take care.